This question, it says it's under theory of logarithms, which means we're going to be using one form of laws of logarithm or the other. But we might use it in this first one, we might not use it. Let's see how it goes. These are your answers. Moses said 2, and he later said 1 over 4. Maybe that's an error, but let's keep it as 2. Taye said 4, Sarah said 4, and Mercy said 1 over 4. The question says if log 10 to base 8 equal x, evaluate log 5 to base 8 in terms of x. Now, if I would rewrite this based on the way the question has been structured, I would say log is 10, base is 8, equal to x. Then I am looking for log of 5 base 8. This is what I'm finding. So the first thing I need to do, just listen carefully, is to find a way of getting these expressions from this expression. I'll repeat that. Find a way of getting this expression out of the first expression. Now, I can see this is 5. So I need a 5 here, and this will be 5 times 2. Just listen. Log 5 times 2 base 8 equal to x. Okay, I have just splitted 10 into 2 times 5. Is that clear? Is that clear?
Yes, sir.
Aha, don't mute yourself, Moses. I want to be sure that everyone is calm and quiet. Now, there is this law of logarithm that states that log of a base b times, when you're multiplying two terms, because it is times between them, you can separate them and say log of the first one, the same base, plus, who is still talking there? Plus log of the second one, the same base. When I'm through, you will do all the talking. So just hold on. Now, this is the principle we're going to use here. This is a theory we're going to use. So that means we're going to separate 5 and 2. Please don't write anything, just listen. So log 5 base 8 plus log 2 base 8 is x according to this. Now you will see that the expression we are looking for is now here, right? The expression we're looking for is now here. Yes or no?
Yes,
Yes,
sir.
This expression is now here, right? Can you see that?
Yes, sir.
Okay, good. So
Yes, sir.
that means we can find it. We can do what? We can find it. So that means we're finding log 5 base 8, and that will be x minus log 2 base 8, because this one is going to come outside to become minus. It was positive. Are you getting that?
Yes, sir.
So it is now the right hand side we're going to deal with to get our final answer, because this is what we are finding and this is the answer. So how do we combine this? It's going to be x minus log of 2 base 2 raised to power 3, because 2 raised to power 3 gives me 8. And there is another theory that says that if you have a log a base b raised to power c, you can rewrite it as 1 over c log a base b. In this case, our bases are the same. So that means we're having something like log a, the same base a log and base, okay? But raised to power b. So that means our answer is going to be 1 over b log a base a. And log of the same base in logarithm will be 1, which means log a base a is 1. Log a base a is 1. So that means this answer here now becomes 1 over b times 1. Then the final answer will be 1 over b. So let us now see how this one play out. Hold on. So I have this finally equal to, let me try to divide this so you don't get it confused in the note. Equal to x minus 1 over 3 log 2 base 2. Then we can say log 2 base 2 is 1. So our answer will become x minus 1 over 3 times 1. And this will be x minus 1 over 3. This is our answer, but we can combine it as a single fraction by finding the LCM of 3. This will be 3x minus 1. So it says evaluate this in terms of x. So this is the answer. Is that clear?
Yes, sir.
Is that clear?
Yes, sir.
Okay, I'm gonna give you like 2 minutes to put down every details on the board. Write it down. Now, question is also another question that is going to allow us to use several, like some theory or laws of logarithm. So let's look at it. The first thing we need to take note of is from indices. When you have root a, it means root a raised power half. Take note of this. So log of this becomes log 4 base a, I mean base 2 raised power half. Take note because of the this one that I explained at the top. Okay, then plus log. Remember from indices also, when you have 1 over a is the same as a raised power minus 1. So you have log 16, then base 2 raised power minus 1. Then minus log, because this is base 2, and we might likely combine them if possible, then we can change the third one also to base 2 raised power 2 log 32. Take note of that. So all of them are in base 2. Then the next thing to do is to take this power to the other side. Or before taking the power, I can as well say this is equal to log 2 square base 2 raised power half. Log 2 square base 2 raised power half plus log 2 raised power 4, because 2 raised power 4 is 16, then base 2 raised power negative 1, then minus log 2 raised power 5, 2 raised power 2. Now remember that if there is log of a power b base c power d, the power d is coming to the back as 1 over d. The power b is coming to the back as just b. Then we still have log a base c. So that means this is going to be b times 1 is b over d log a base c. So that means the power of the log is going to stand as whole number at the back. The power of the base is going to stand as inverse or reciprocal at the back. So let's continue with what we're looking at. Now this 2 is coming to the back and this half is also coming to the back. But the half will be 1 over half, which is 1 over half is, what is 1 divided by half? That is 1 divided by half, which is 1 times 2 over 1. So 1 over half is 2. We're going to take that to the back. Hold on. I want to remove some markings I did here. So with this, we have this equal to 2 that is coming, which is the power then times 1 over half, which is the 1 over the base, the power of the base. Then log 2 base 2. Then the other side, this minus is coming over as minus 1, but minus 1 over 1 is still uh, minus 1. So that one will not reflect the 1 there. So, but the 4 is coming to become 4. So we have 4 times minus 1 over 1, which is also minus 4. So with that, we have this at the back. This plus is going away. Like we say plus the 4 times 1 over negative 1, then log 2 base 2. Then this 5 is coming, this 2 is coming. The powers are coming. So we have minus log 5 times 1 over 2. Oh, sorry, minus 5 times 1 over 2, not log. 5 times 1 over 2, then log 2 base 2. Log 2 base 2. So with this, we can cancel out all of the log of the same, base to be 1. Then we have the 2 times 1 over half. 1 over half is 2, so 2 times 2 is 4. Then the other side, we have negative 4. Then we have 5 times 1 is 5 over 2. So minus 5 over 2. So we now have 4 minus 4 is 0. 4 minus 4 is 0. And your answer is minus 5 over 2 or minus 2.5. That's why I said your answer is correct. The answer you gave me is correct. But we need to really see how to do it so that if we need that principle in another question, we know what to do. Is that clear?
Yes, sir.
Okay, so I'll give you some time to write this down for as many that want to write it down, just 2 minutes. And your 2 minutes starts now. So after 2 minutes, somebody said, I'm not true. Just going to continue. Question. It's another question that will involve the use of theory of logarithm. And this time around, the theory we'll be using is something that says that if you have log A base B equals C, you can change it back and it becomes A equal B raised to power C. Please, are you looking at this, Sarah? Now,
Yes,
what's
sir.
our A? For this question, what's our A? Our A is 64. What's our B? Our B is x raised to power half. What's our C? Our C is 3. So we can say log 64 base x raised to power half equal to 3 will be expressed as 64 equal to x raised to power half also raised to power 3. And there comes in another law that says that if you have an element or a number, raised to a power and raised to another power, you're just gonna say the first one to the power of the second one times power of to the second power. So this is gonna be, or let me just use another letter like n. It's gonna be a raised to power m times n, and your answer will be a raised to power mn. Are you seeing this?
Yes.
Are you getting
Yes,
this?
sir.
Okay, good,
Father, please.
good.
Yes, sir.
Good. Now we have 64. Somebody is talking there. Somebody's making a noise. 64 equal to x raised by half times 3. And half times 3 is 3 over 2. So what we can do here now is to realize that there is another law that says that if you have a number raised to power a number over a number. This is going to be seat root of a raised to power b. If it is 2, that'll be square root. If c is 2, that'll be square root. If c is 3, that'll be cube root. If c is 4, that'll be fourth root. Whatever c is, it is the root of a that is going to give us that particular one. Now, so we're going to split, interpret this as square root of x raised power 3. So 64 equal to square root of x. Why do we use square root? Because of 2 here. So square root of x raised power 3.
Take it no.
Now to remove
Get
to
to the
remove
state.
the somebody is talking. To remove the power of 3, you cube root both sides. So you find cube root. Cube root. Let me use another color there so you can. So you find the cube root of 64 and find the cube root of this other side. So cube root to cancel the power of 3. What's the cube root of 64? That's 4 equal to root x. Then to remove the square root, you square both sides. Square both sides. Once you square both sides, this removes this. Can you hear me?
Yes, sir.
So x is going to be 16 because that's 4 square. It's another one that will allow us to explore a kind of theorem or theory of logarithm. This is what we want to evaluate on the right side here. And these are what we have, 2 and 7. So we have to bring 2 and 7 out of 280. The best way to do that is just to say log, that's equal to log 28 times 10, base 10. And this is now going to be log 4 times 7 times 10, base 10. And this is going to be log
So
4 base 10 plus log 7 base 10 plus log 10 base 10. So log 4 base 10 can be rewritten as log 2 square base 10 plus we have been given log 7 base 10 to be 0.8451. Then we know that log 10 base 10 is 1. So this is going to be 2 log 2 base 10 plus 1.8451. Then we have log 2 base
one
10
instead
as,
of zero.
what do you mean? Which one?
Log 7 base 10. It's supposed to be 0.8451, not 1.8451.
Oh,
So did you understand?
what is this?
Sir, log 7 base 10,
What is
right?
this one?
Supposed
What
to
is
be.
this?
Okay,
Sarah,
okay, okay.
you had this together.
So I wasn't listening at all. Yes,
Uh-huh.
yes, I saw it.
Uh-huh. So that's what gave me this. So now we have been given log 2 base 10 as 0.3010. So we have 2 times 0.3010 plus 1.8451. Then we're going to multiply this by 2. So that's going to be 0.6020 plus 1.8451. Okay? Okay. Can you hear me?
So
So this is going to be our final answer is going to be the addition of this because we say 2 times 0.301 is 0.6020 plus 1.8451. That will be 2.4471. Okay? 71. So Sarah and Messi, you are on the way, but you missed one at the end. Okay?
sir, Sir Messi said it's not important. Why are you taking from me? Are you making more
Eh,
honest? I don't understand.
wait. Why it will be, listen, logarithms are given in 4 figures after decimal. So it has to be complete. Is that clear?
This one is not. Look at the sheet.
Is that clear now?